Okay. For each sequence, state if it's arithmetic, geometric, or neither. Okay, so just to remind you, arithmetic is plus and minus, the same thing each time. Geometric is multiplication, which I guess I'll do a dot. And neither is neither of those. Okay, what is happening to number 1? Times 3, correct? Does it look like times 3 to you guys? Okay, so that is geometric. Number 2, adding 7, arithmetic. Okay, what's happening in this one? Adding 10? Yep, arithmetic. And this guy, it looks weird to me, neither. Yes, honey. Nope. Um, the only thing is, like, if it asks you for something easy, like in this one, let's just say it said find T of 4. You could find T of 4 because it's in your list, but you could not find the equation. So if that's what you mean by like solving, okay. Actually, it's really fun that you asked that question. It's like we planned it ahead of time. So on the block day, we're doing something that's like a scavenger hunt thing, and some of the sequences are neither. And I was just going to make sure that you guys knew you do not find the equation for those. You're only doing equations for arithmetics and geometrics. Excellent question. Keep those coming. Okay. Number 5. Find the common difference, the term named in the problem, explicit formula, and the recursive formula. Okay, for this, I'm going to do it kind of in a different order. I find the common difference, then I'm going to do the explicit because the explicit helps me get the term named in the problem, and then I'll do the recursive last. The first thing I like to do is my arrows, though. So I'm going to do a forward arrow. There's not enough room to do it underneath, so I'm going to do it on top, and then my backward arrow. And that's where I start basically every time. What is this one doing? Up 10? Everybody agree it's up 10? Okay. And then what would term 0 be? 18. Great. Okay. So T of n equals 10 and plus 18. And remember, this is like y equals mx plus b. Now, because this is notes, you might just want to label that as your explicit. As you could see, I'm too lazy to write the whole word explicit, but that's fine. We got the idea. Okay, now, as I said, the explicit is helpful because it's like your portal gun. It helps you get anywhere you want. And I want to go to term 37. So T37 equals 10 times 37 plus 18. Which is, I feel like I could have done that without a calculator. Now that I think about it, I feel kind of stupid, but that's okay. Okay, so I found that, oh, I didn't say the common difference, but that's okay. I did right there. So common difference is 10. The term named in the problem, 37th term is 388. I found the explicit. And now I'm going to do the recursive. The recursive has two parts. And this part is the same for every single problem. So for every single recursive, I just write that down. Yes, honey. Okay, let me ask you this. Did it say this instead of that? Okay, hold that thought. Okay, so this, well, this right here is the same as this. These two things are saying the same thing. It's just saying that this one is down one from this. This is saying this is down one from this. So it's just a different way of saying exactly the same thing. So we'll see. But for us, when you're writing your recursive, I always write them the same way. You must know there's infinite ways to write them because sequences are infinite. They go on forever. But I feel like it's easiest to just write them the same way every time. Okay, so first term was 28. To get the next term, I take the current term and add 10 each time. Okay, any questions about number 5? Okay, number 6. Given two terms in an arithmetic sequence, find the common difference, the first 5 terms, the term named in the problem, the explicit and the recursive. Holy cannoli, it's asking for everything. And it didn't really give me the sequence like this one did. I have to find it. Okay, so for a problem like number 6, I like to switch myself into chapter 2 mode, and I will make these into coordinates. And then I'll find the equation of the line using chapter 2 stuff. So slope equals y2 minus y1 over x2 minus x1. Oh man, I was a little nervous there. That was going to be a terrible number, but it came out evenly. Nice. Did anyone know that 19 times 9 is 171? I had no idea. Okay, which point do you want to use? The first one because it's lower numbers? What's wrong? Did I screw up? It's possible. Okay, so freeze there. Everybody good so far? You guys understand what I did? Anyone good? You sure? Okay, now what I'm going to do is I'm going to take this and make it look like this one. So I'm going to take the y equals mx plus b and I'm going to change it to look like the explicit of a sequence. And all that changes is the symbols. So t of n equals 9n minus 21. So notice it's exactly the same thing, just y changes to t of n and x changes to n. Okay, what does the explicit help me do? Get any number I want, right? So it wants me to find term 32. Okay, now let's go back up to the problem, see what else we need to do. Given two terms in an arithmetic sequence, find the common difference. Remember, the common difference is just the slope. You found it. I just wanted to put D. The first five terms, I did not do that yet. The term named in the problem, I did that. The explicit, I did that. Okay, so we need to find the first five terms and the recursive. Okay, so what is term 0? Let me give you a hint. What is term 0? Negative 21. Okay, and I'm going to put that on a blank with an arrow going like this. Does that make sense to you guys? Okay, now they're going up 9 each time. So what's negative 21 plus 9? Negative 12. Plus 9. Plus 9. Plus 9. Plus 9. That's not plus 9. Okay, what's the last thing I need to do? Your favorite, recursive. Okay, so I just wrote that down straight out of memory every single time, the same thing. Term 1, I'm getting these answers from my sequence down here. Term 1 is negative 12, and they're going up by 9 each time. So here's my question. Did I answer all the questions in the question? Did I do everything? Did I find the common difference? Yes. Did I find the first time 5 terms? Yes. Did I find the term named in the problem? Yes. Did I find the explicit? Yes. Did I find the recursive? Yes. Oh, look at me go. Nice job. Okay. Any questions about number 6 before I move on to number 7? From 6 to 7? I'm going to go from problem 6 to problem 7. I wasn't going to say anything till Payson gave me the face, but then I had to just make it even worse. So I should go to problem 7 now from problem 6. I should leave problem 6 and go to problem 7, is what you're saying. I feel like that's what you're saying. Stop doing problem 6 and now start doing problem 7. Have fun at your job, people. That's my advice for life. Find the common ratio, the term named in the problem, the explicit, and the recursive. Alrighty, this guy's geometric, so that means your growth is called R, which is common ratio. I'm still gonna do my arrows though. So I do a forward arrow and a backward arrow. I'll start all of those problems the same. It looks like this one is multiplying by 5. And what do I do? How do I'm completely lost. I'm not really completely lost. Yes, honey. So what do I do? So you want to multiply by 5 to go this way. So I want to divide by 5 to go that way. So -2 divided by 5 is -0.4. You might want to make yourself a little note. Okay, so find the common ratio. That's R is 5. Multiplier is 5. And just like these other problems, I'm going to find the explicit first because the explicit is my portal gun. It gets me anywhere I want to go. And in this problem, I might just multiply out to term 9 if I wasn't feeling like I had to find the explicit, but I'm going to because it says to. Okay, so explicit is T of n equals term 0 times R to the n. So term 0 times R to the n. And then it says find term 9. Make sure that you guys know how to do the exponent on your calculator, whatever calculator you have. That's a big number. Okay, what's left to do still? Recursive? Okay, start the problem the same way every time. Yeah, honey. You do, so, okay, PEMDAS, parentheses first, there's nothing in the parentheses. Yeah, so do 5 to the 9 and then times -0.4. Okay, first term on this problem is -2. To get the next term, I take the current term and times by 5 each time. Okay, guys, flip to the back side whenever you're ready. All right, what do we have on the back? Fraction Buster? Hmm, lots of fun equation. Okay. All right. Number 8 is a fraction buster. What is the least common denominator? 24. Great job. Okay, so multiply everything by 24, including the 3v. And when I say everything, I mean just the numerators. Okay, so 3 times 24 is 72. 24 times 5 is 120. 24 times 23 is 552. 24 times 55. Okay, so multiply everything by 24, then divide down. Okay, now when I have variables on both sides, I like to undo the smallest thing with a letter first. So minus 72v. Minus 55. Okay, what number goes into both negative 75 and 20? 5. However, too lazy. Okay, number 9. What do I need for number 9? I need something special. Box, yep. And I'm going to do the box off to the side over here. Okay. And then on this side, I have to be really careful with the distributive property of -6. Okay, so I'm going to give you guys a second to catch up. Okay, so I have 1 minus 18 plus 6x squared. Let me just make sure that looks right. So I have 1 minus 18 plus 6x squared. Okay, good. Equals, and then this side, I'm going to combine those two like terms there. So I have 6x squared minus 11x minus 35. Okay, does that make sense so far? Okay, now I'm going to combine these. So I have -17 plus 6x squared equals 6x squared minus 11x minus 35. Okay, now I'm going to cancel out the 6x squared. And the x squared should cancel out on all of your problems this year. Not next year, but this year. Plus 35. You guys get 18 over -11 before me? And that is as reduced as that will go. Okay. Number 10 and 11 are both same base exponential equations. Number 10 already has the same base, which is exciting. I can just cross it out. 3p equals 2 minus 2p. Add 2p. 5p equals 2. P equals 2. This. Oh man, that one was great. I like that one. Okay, however, number 11 are 2 and 64 the same number. You really want them to be, but they're not. Okay, so 64 is 32 times 2, which is 16 times 2, which is 8 times 2, which is 4 times 2, 2 times 2. Okay, so 64 is 2 to the what? 2 to the 6. And I can tell because there's 1, 2, 3, 4, 5, 6 2's at the bottom of my factor tree branches. So 2 to the negative 2m minus 3 equals 2 to the 6. Now, are the 2's the same number? Yes. Trying to figure out which homework problem we're talking about. Because it's going to bug me. I don't know. Okay. All right. Number 12. Number 12, this side is square rooted, so I need to square both sides to get rid of the square root. And when you square both sides, on this side, the square root and square root cancel, and it's just 6 minus 2r. And on this side, 4 squared is 16. Minus 6. Whole number answer. Satisfying. Okay, number 13. This one's spicy. Solve each equation by taking square roots. Okay, you don't take a square root right now. So you can't square root it yet until the squared is by itself. So I have to do this part first. I have to minus 9 from both sides. It's already starting to look better. I still can't square root it. Now this makes sense to square root. However, there are actually two answers. Yes, plus or minus, beautiful. So make yourself a note. It says when square rooting both sides, it's my little symbols. Remember plus or minus. It's not you, it's me. Was there one of those on the team test? Did you remember the plus or minus? Or did you have to look at the team test key and then get reminded of the plus or minus? And be like, oh yeah, that whole thing. The plus or minus like is all over my math 3 class right now. Like everything they're doing, they have to remember plus or minus. It's really funny. Okay, now we have some old stuff. Just reminders because we have your final coming up, which is cumulative. So I just wanted to remind you how to do some old things. So this is parallel. So you write parallel slope x, y. And the parallel slope to -1/5 is still -1/5. X is -5, y is 0. Oh no, I messed up. See how I messed up? Anybody see how I messed up? I put 5 instead of negative. Okay, what is -1/5 times -5? This is supposed to take you 1 second to answer. One. Good job. If it doesn't take you 1 second to answer, it's okay. You have a calculator. Okay. Now number 15 says perpendicular. It actually only says perp, but it means perpendicular. Does anybody remember what to do with the slope when it's perpendicular? Flip it and change the sign. So it's going to become -7/5. Okay, what is -7/5 times 5? And it should be a 1 second answer. -35 over 5, which is -7. Yeah, so the 5's just cancel. Ah, okay. Now, last thing. On number 16 and 17, if you guys could add in these two facts that I found on the internet before you got here with my Googling. I did a bunch of Googling. I also, do you guys know this about me that I really like different beverages? Like, I told you about my peppermint mocha, by the way, which destroyed my stomach yesterday. It was terrible, terrible. Like, made my stomach hurt really, really bad. I could only drink like half of it. Anyway, beside the point, I really like Coke Zero. Do you know this about me? Does anybody know this about me? Do you know that there is a full case of Coke Zero in the teacher's lounge fridge? Just for me? Did you know that? Did you had no idea? Okay. So I went in there before school and I was like, I wonder how many milliliters are in the Coke Zero cans. I literally looked just to make sure that I did this problem correctly. So we can find out the mystery of how many milliliters are in Mrs. Talbot's giant case of Coke Zero cans right now. Okay. How many milliliters are in a 12-ounce soda can? So I start with 12 ounces. This one is not a rate, so it's just 12 ounces, and I make my times line like this. And if you want to, you can put it over 1 if that makes you happy. And what should go on the bottom if ounces is on the top up here? Ounces, liters. So I looked this up before you got here, and there's 33.8 ounces in 1 liter of anything, not just delicious, delicious Coke Zero. Have you guys had the strawberries and cream Dr. Pepper? It's like straight up candy in a can. Okay, anyway. Okay, so I cancel out the ounces. And now I'm in liters, but I want to be in milliliters. So I'm going to put liters on the bottom. How many milliliters are in a liter? You guys should know this from science. What's milli? 1,000. Nice. And you're thinking to yourself, Mrs. Talbot, it's okay because I have the Google. I don't need to do these problems. The Google will tell me. And you're not wrong. Okay, so I'm going to go 12 divided by 33.8 times 1,000. So remember, you divide by the ones on the bottom and multiply by the ones on the top. 355.1 milliliters. Nope, it's just 355.0. I'm going to do 12 divided by 33.8 times 1,000. 355.0 milliliters. So next time you have a soda, you got to check the side of the can. Last one. Am I going to have time to pass papers back? I really, really want to. In a recent Grand Prix, the winner completed the race with an average speed of 229.8 kilometers in 1 hour. What was the speed in feet per second? So this one's different. They gave you a rate, so I need to set it up as a fraction like this. And I looked it up, and 1 kilometer is 0.621 miles. Kilometers on the top. So I'm going to put kilometers on the bottom, miles on the top. 1 kilometer is 0.621 miles. Did you guys know that a kilometer is like just a little more than half a mile? I mean, I've run a 5K before. I've run lots of 5Ks. I guess I should have known that because it's 5Ks, like 3.1 miles. Anyway, okay. Now I want to be in feet per second. Am I in feet per second right now? No. What am I in? Miles per hour, right? Okay, so I'm gonna keep working on miles. How many feet are in a mile? Yep. Okay, so now I'm in feet per hour and I need to get hours to seconds. Do you guys want to go directly to seconds or do you want to go to minutes and then minutes to seconds? To minutes? Okay. So 1 hour is 60 minutes. So now I'm in feet per minute. Holy shnikes, this is a long one. You guys know the movie that Holy Shnikes is from? Okay, it's from Tommy Boy. It's got Chris Farley in it. Anyone like Chris Farley? Anyway, so 0.621, so times 0.621 times 5,280 divided by 60, divided by 60, 209.3 feet per second. That can't be real. That's so fast. I guess 229. Okay, anyway.